Good morning. Welcome back to the cloud computing tutorial. Today we are going to see about infrastructure as a service providers and platform as a service providers, their features. First topic is infrastructure as a service providers. Public infrastructure as a service provider will offer generally virtual servers which contains one or more CPUs running the several operating systems in those servers and the customized service stack. So all these are the components in the infrastructure as a service providers. In addition to all these things, it also offers the storage space and the communication facilities for establishing the communication between the user and the cloud. Next, coming to the features of this infrastructure as a service providers, the first feature is geographic presence. In order to improve the availability and responsiveness, a provider of worldwide services will offer or will build the several data centers distributed around the world. For example, if you take Amazon Web Services is the one service provider, one cloud service provider. This Amazon Web Services are build availability zones and the regions. Region is nothing but the geographical area. Availability zone is nothing but the physical data centers existed. If you take the region in India we have two availability zones. One region is there in Mumbai. Mumbai is the region. In that Mumbai region, two availability zones are there. Generally, when AWS set up their regions availability zones, if one region may have two or more availability zones, the reason behind for providing two or more availability zone in one region is to ensure the backup for the user's data. If anything goes wrong with the one availability zone, and the users will get the data from the second availability zone, and these availability zones are set up one from another between the 70 to 80 kilometers distance. User interfaces and access to the servers. So generally IaaS provider, they must provide multiple access. It means to cloud, their catering for various users and their preferences. And for accessing the services of the cloud, the service provider must offer user interfaces. There are different types of user interfaces are there. For example, graphical user interface, command line interface, and web services APIs. These are the few different types of user interfaces for accessing the services of the cloud. Coming to the second feature, advanced reservation of capacity. So generally users will request for infrastructure to provide the resources for a specific time for using in future. So this ensures the resources will be available in that time. If users will make the reservation for the resources, it will decreases the charges for the utilization period. Example, if you take Amazon reserved instances is a form of advanced reservation of capacity. The users to pay a fixed amount of money in advance to the resources for availability of all the resources at any time during the agree period, and then we pay the discounted hourly rate when resources are in use. For example, if user is set up the instances 1 year, so in that 1 year duration of time, users are going to be use the resources on the agreement basis. So in that duration, the resources incur charges will be paid by the user. This is the meaning of advanced reservation of capacity. Coming to the next feature, automatic scaling and load balancing. This automatic scaling is the most important feature of IaaS clouds. And load balancing. Load balancing is distributing the incoming traffic across all the servers. This automatic scaling allows users to set condition when they want to increase the server capacity and when they want to decrease the server capacity, and this feature is automatically set to scale up, scale down the server, scale down the server capacity based on the application demand, and such as transactions per second, the number of simultaneous users are accessing the server, and request latency, and so on. These are the several parameters that are considered when automatic scaling is deploying. Service level agreement, this is the next feature. So the service level agreement offered by the IaaS providers to express their commitment to deliver the certain quality of service parameters. So to ensure this, the customer serve as a warranty. Warranty will be provided by the service provider according to the service level agreement. So according to the service level agreement, the services will be available and the performance guarantee will be achieved. For example, if you take Amazon EC2 instances, so it states that annual uptime percentage for a customer dropped is 99.95% for the service in a year. So if the customer is eligible to receive the service credit which is equal to the 10% of their bill. It means if the Amazon is unable to provide the service level up to the 99.95%, the customers are eligible to receive the credits from the service provider, that is Amazon. Next, coming to the hypervisor and operating system choice. Traditionally, IaaS offers have been based on the heavily customized open source Xen deployments. Xen is the one type of hypervisor. Hypervisor ensures that running multiple guest operating system on a single physical host. We have the different types of the hypervisors. So Xen is among one hypervisor. IaaS providers need expertise in Linux networking, virtualization, metering in the sense what, billing cycles, resource management, and other level aspects in order to deploy and maintain the cloud offering services. So the user has to expertise in the Linux networking, virtualization, metering, and the resource management, and other aspects for deploying the cloud services on their systems. So these are all the several features of that offered public infrastructure as a service. Next, coming to the platform as a service providers. So generally, platform as a service provider is one layer of cloud services. So this platform as a service provider typically provides a platform to the developers. So users need not to worry about the background details. Rather, they are focusing on the application scenario. So let us see one by one. Before going to the features, we'll see the brief summary of platform as a service provider. So platform as a service provider commonly offer the development and deployment environment. So this development and deployment environment allow users to create and run the applications with low level details of the platform. So this platform as a service provider offers deployment as well as a development environment to run the users applications. Coming to the features of PaaS, platform as a service providers. The first feature is programming models, languages and framework. So this platform as a service provider offers the different programming models, languages and frameworks. So users has to run the applications on a different programming models, languages and frameworks. So for example, it supports for the various platforms, Python and Java for the Google App Engine platform, .NET language for Microsoft Azure platform, Ruby for Heroku platform, Force.com is a platform as a service by the Salesforce.com and which supports Apex programming language. This programming language is purely for the Salesforce.com. This programming language is a Excel-like query language. So here in this PaaS feature, users will run the applications they focus on the application scenario instead of how that application will run on background. In addition to the programming languages and models, it also supports the software frameworks. So these frameworks are available to the PaaS developers depending on the application focus. The service providers focus on web and enterprise application hosting, offer popular frameworks. The popular frameworks are Ruby on Rails, Spring Framework, Java Enterprise Edition Framework, and .NET Framework offered by the Microsoft. And in addition to these framework, persistence options is another feature. So this persistence option is essential to allow applications to record their state and recover in case of failures, as well as to store the data. For example, Amazon Simple Database and Google App Engine Data Store offer schemaless automatically indexed database services to record the state of the application, and if the problems arises in the current state running applications, it is recovered from the crashes, and also this option is used to store the user data. So these are the features of platform as a service providers. Coming to the challenges and risk. So when you are thinking about the cloud services, the cloud service provider also face few challenges and risk. So let us see one by one. Security, privacy and trust. Data security is the most important parameter when we are switching our applications to the cloud. User data as well as organization data are going to be stored in the cloud. So is a private data. Even the service provider will give the assurance that is the data integrity. It is our responsibility to carry out the user authentication, authorization, identity management, data encryption and access control. User authentication. So as a owner of the user, we must ensure the authentication to the only the few people are authorized people. Identity management will give the feature that we have to create the several accounts to the corresponding users. A data encryption, keeping the data in a encrypted format, it is the responsibility of the user. Access control, so it will be done at different levels. Security issues on the cloud, those are include identity theft, data breaches, malware infections, and many more. So these security issues will increase the trust on the application usage. So we must take care about all these security issues. Legal and regulatory issues, these two issues also need to be attention. When we are moving data to the cloud, the providers may choose to locate the data anywhere in the planet. The physical locations of the data center determines the set of laws that can be applied to the management of data. So when we are keeping the data in the cloud, that is with respect to the location, we must obey the local government rules and regulations. For example, cryptography techniques, these techniques could not be allowed in some countries, and those cryptography techniques are allowed in some countries. So we must take care about the legal and regulatory issues related to the place where we are keeping our data. Similarly, country laws can impose the sensitive data such as patient health records are to be stored within the national borders. Data lock-in and standardization. The most important consideration in cloud computing is data lock-in by the service provider. So that is for preventing users from moving data between the cloud service providers and applications if the users' requirements are not met by the service provider. So in such cases, users will think about the other service providers which are satisfied by the other service provider. So as of now, the current cloud infrastructure lacking standardized methods for storing data as well as application, which leads to the interoperability issues and non-portable data. So to address these issues, the Cloud Computing Interoperability Forum, it is one forum which has built with the many different cloud organization like Intel, Sun Microsystems, Cisco, and many organizations are there. These are created global cloud ecosystem for seamless industry-wide adoption of your cloud computing. And these organizations forum CCIF developing the unified cloud interface for standardized access to the cloud infrastructure. With this interface, users can access the services according to their requirement. In addition to this, in hardware virtualization, the open virtual format. So this format is designed to facilitate the portability of virtual applications across the different hypervisors. So this is also implemented in the unified cloud interface. The next challenge is availability, fault tolerance, and disaster recovery. So generally users will expect the service level when moving their applications to the cloud. So they expect maximum availability of the application, high performance, and measures for handling any issues. So they seek that warranty to confidentiality, transition to their business to the cloud. So to answer these, the service level agreement between the customers and the cloud service providers will be made as a warranty. So the service level agreement also includes agreed upon metrics and penalties if the service provider is unable to meet the customer expectations. Resource management and energy efficiency. So efficiently managing virtual resource pools is the key challenge. So efficient utilization of the virtual resources. So for example, CPU cores, disk space, network bandwidth, distribution of these resources among the virtual machine is the key challenge for the service provider. Next, mapping of virtual machines to the physical host. This is also important challenge faced by the service provider. Mapping of the virtual machines to the different physical machines. While mapping should be done, so the different dimensions will be considered, such as CPU count, memory size, virtual disk size, network bandwidth. Dynamic virtual machine mapping policies can involve suspending a virtual machine, migrating to the another virtual machine, and resuming virtual machines in order to prioritize high priority allocations. So these three things will be done with the dynamic virtual machine: suspending virtual machine, migrating virtual machine, resuming virtual machines. Next, it also provides the live virtual machine migration, which is used to balance data center loads. So it must weigh the performance impact against the benefits. So the live migration, so when we are performing the live migration, we must bear the performance, that is either the performance may be degraded or performance may not be degraded. So we should take care about the performance of an application when we are performing live migration, virtual machine migration. Next, dynamic provisioning and replication of virtual machines. So it requires efficient mechanisms to quickly make virtual machine storage devices available at selected host. So it also provides replication of virtual machines. So we can easily get the backup with the available virtual machines. Data centers consume large amount of electricity. This is another challenge. So with significant monetary costs and environmental impact due to the CO2 emissions from cooling system. So we have to reduce the consumption of the electricity. Next challenge is dynamic resource management can optimize application performance. So we should improve the utilization and reduce energy consumption by consolidating workloads onto the fewer servers and turning off ideal resources. So in order to utilize the dynamic resources, we have to turn off the ideal resources to reduce the energy consumption and consolidating the workload. These are the several challenges we must take care while moving or while choosing the cloud to the user applications. Thank you.